Hello, I'm Robert Keevil, CEO of American Micro Detection Systems. American Micro Detection Systems is a technology company that develops water quality analysis instruments that register down to the part per billion level. We maintain research and development facilities in Livermore, California, and our corporate office is in Stockton, California. In a moment, you will meet Mr. Charles Bupp, our senior scientist, who will explain to you the operation of the REX unit and provide a short, quick demo. If you have any questions, please feel free to browse our website or contact us directly.
Hi, I'm Charlie Bupp, Senior Scientist with AMDS. I'm going to show you the basic theory of operation behind the REX instrument. We have a water flow going through our double layer capacitor. We have a capacitive deionization process. However, first we start with a blank measurement where the water flows and the cell is shorted. After we collect our background measurements, we then collect measurements with the cell energized with a positive potential on one plate and a negative potential on the other. This leads to an accumulation of ions on the surface of the electrodes in a reversible capacitive deionization process. As you look inside REX, here we will see cutting-edge technologies at work. The metal chassis and all of the metal components of the instrument are built with 304 stainless steel. Here we have the high voltage power supply for providing the X-ray tube with the juice it needs. We have our logic board for internal communications within the instrument. We have an embedded processor running an embedded version of Windows with an Intel Atom processor for data processing and signal analysis. We have an Ethernet switch for internal distribution of communication. Relays to work with the interlocks so that all components are interlocked for safety purposes. We have our X-ray tube for X-ray fluorescence excitation. Our X-ray detector for X-ray fluorescence emissions. This is a state-of-the-art AmpTech silicon drift detector. And here is our main attachment body, which contains our mesoporous nanocellular carbon aerogel foam collection cell. For this cell, water goes in, power goes in, and the ions are accumulated on the surface where they are analyzed with our X-ray fluorescence methods. Here you can see the exterior of the instrument. This is a rapid injection molded case, which provides shielding from internal radiation and shields the instrument from external elements. The case is 17 inches high by 16.4 inches wide and 18.5 inches deep. The weight of the entire system is approximately 34 pounds. Here you can see the interfaces for the REX instrument. On the right side, you can see the water input and output. Next to that, you can see 9 process control outputs. That's the green connector. Next to that is the USB connection for attaching external communications hardware. To the left of that are 2 Ethernet ports for direct physical wired communications. Next to that is the power supply and a physical switch for turning the instrument on and off at a power level. Next to that are warning lights for power and fault conditions. If the fault condition is triggered, the instrument will automatically shut itself off and trigger any process control outputs that the user has configured. We are now doing a 60-minute analysis with water containing chromium at a level 2 to 3 orders of magnitude lower than XRF could detect without pre-concentration. In a factory or process control situation, water is plumbed directly from the source through a 5-micron filter, if required, and then onto the instrument. The operating parameters are a flow rate of 40 milliliters per minute and a cell potential of 0.6 volts. The software is factory preloaded with all operating parameters for the X-ray tube and the X-ray detector. For initial configuration, the end user selects elements of interest, frequency of analysis, and where they would like the text data files set. With our 60-minute analysis completed, this is our background subtracted spectrum. The blue peak is the chromium K-alpha peak. The red peak is the chromium K-beta peak. And this is what the customer will receive, the post-analysis report. Note that the calculated chromium concentration is in agreement with the known concentration of the standard.
I want to thank you for taking the time to look at AMDS and our product, REX. And I want to leave you with the following highlights. We have the only instrument in the world that reads to part per billion levels at the source of concern in near real time. We have no consumables, and we send data files anywhere the end user selects via either Ethernet, satellite uplink, or wireless. We eliminate grab sampling. We just take the sample, analyze it, send the data anywhere that the end user selects. From all of us here at AMDS, I want to thank you for taking the time to watch this video. We look forward to hearing from you very soon.